So question 22, working with polynomials. Notice how now we have a trinomial, I'm sorry, a binomial times a trinomial. So we have a two-termed expression times a three-termed expression. So again, if I had, say, 321 times, say, 42, mathematically, I could do this problem, 2 times 1 would be 2, 2 times 2 would be 4, 2 times 3 is 6, and then we can use 0 as a placeholder because this is technically not a 4, but a 40. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and then if we bring the math down, we have a 2, an 8, a 14, a 3, and then so it's like 13,482. Now, instead of doing it like that, we could write this as 42 times 321. So I can use parentheses to show multiplication. Now I could change 42 to a binomial, 40 and a 2. And I could change 321 to a trinomial, 320 and 1. Now to do the math, what we're really doing is using distributive property. We're going to multiply this 40 through all three pieces, and then we're going to turn around and multiply this 2 through all pieces. So 40 times 300, that's going to be a 12 and three zeros, so 12,000. 40 times 20 would be 800. So it's 4 times 2, which is 8, two trailing zeros, 800. 40 times 1 would be 40. Then if I multiply the 2 through, 2 times 300 would be 600. And 2 times 20 would be 40. And 2 times 1 would be 2. So if we do the math, I'm seeing a 2 and an 80. And this is going to be 1,400 and a 1,200. Or sorry, I'm sorry, 12,000. So 12,000 and then 1,400 would be 13,400 plus 80 plus 2. That's going to be 13,482. So that math does play out. So we can multiply using parentheses and the distributive property. So this problem right here really doesn't match this very well. This doesn't work, but notice how this math does work for this problem. So again, we can use the distributive property and multiply this through. Now, when I have a binomial times a trinomial, a lot of times I'll use a box as an organizer. So I'll actually draw this using a rectangle. So I'll put the x and 4 on one edge, and I'll put the x squared and the negative 6x and the 5 across the top. And then I'll partition this way, and then I'll make some partitions this way. So this gives me organization. So what I can do then is multiply the x through all three pieces, just like we would be doing over here, but just in the form of a box. X times x squared is going to be x cubed. X times negative 6x is going to be negative 6x squared. And x times 5 would be 5x. 4 times x squared would be 4x squared. 4 times negative 6x would be negative 24x. And 4 times 5 would be 20. Now, when I do the box method, though, what's catchy is the like terms are actually diagonal. So when we combine like terms, they're actually in a diagonal format. So some people don't like that. So when I play this out, though, the x cubed would come down, and then 4x squared and negative 6x squared. Remember, these are like terms, so you combine the coefficients to keep the variable part. That's going to be a minus 2x squared. And then the negative 24x and the 5x, again, we have like terms. So negative 24 and a 5 would give me a negative 19x. And then the 20 would be coming down. So I'd have that. Now, some people do not like the box, which is fine. You can also just distribute the x through all three pieces. So x times x squared is x cubed. X times negative 6x is negative 6x squared. X times 5 is 5x. And then you can multiply the 4 through all three pieces. 1, 2, 3, this way. So 4 times x squared is positive 4x squared. And notice where I put it at. I put it up underneath its like term. 4 times negative 6x is going to be a minus 24x, so it goes here, and 4 times 5 would be a 20. So you can also do it without the box and just bring down the 20. It's going to be a positive. That's going to be a negative 19x. And then this is going to be a minus negative 19x. And then this is going to be a minus 2x squared. And then this is going to be x cubed. Or again, you could go from left to right. X cubed minus 2x squared minus 19x plus 20. It may be easier to add from left to right than from right to left, since we have that going on there. So again, addition order does not matter on this. You can go this way or this way. It may make better sense to go from left to right. So essentially, a binomial times a trinomial, since we're trying to find the product, we actually are using what's called the de Sitter property. So to remove the parentheses, we have to multiply through the addition.